Hello everybody. Today we start with a new chapter in physics for standard 10th ICSE, and that's about sound. So we are referring to Concise physics textbook, and we are on chapter number 7, sound. The chapter sound is as such divided into three parts. The first part of the chapter is based on a recap of the 9th standard a bit, and then about echo. So the first part is about the echo and the applications of echo. The second part is about the different types of waves, or we can say different kind of vibrations. So the force vibrations and the resonance and those kinds. So that is the second part, and the third part is about the different characteristics of sound. So these are the three different types of the different forms, or we can say the different sections of the chapter. In the first section, related to the echo, we have the numericals, but in the later two parts, we do not have any numericals. So, numerical wise, yes, there are numericals in sound also. So let's see with we now do certain kind of a recap of what we learned in standard 9th. So let's start with the chapter sound waves. Reflection of sound and echo is the part of the chapter. So first thing is sound waves. In class 9th, we have read that sound is produced when a body vibrates, and it reaches us through the vibration of the particles of the surrounding medium. Thus, sound requires a medium for its propagation. So we very well know that sound is a form of energy and it is produced due to vibration. So the mechanical vibrations of any object is going to cause the sound to be produced, and it is going to propagate from one place to another place, or from the source to our ears through a medium. It requires a material medium for its propagation, and so sound is going to be a energy which is produced by vibration, and it requires material medium for its propagation, is what was the main thing what we learned in the 9th standard. A vibrating body causes vibrations in the particle of the surrounding medium, which travels in the form of waves with a certain speed, depending upon the density and elasticity of the medium. So the next thing what we learned about in the 9th standard was about the propagation of sound in different mediums. So we understood that the sound is going to travel through the medium wherein the speed of the sound will depend upon the density or of the medium in which it is traveling. More the density, more will be the speed in which it is traveling. So and also about the elasticity of the material. So the material should be elastic in nature. It should be such that it will come back to its original position, so that vibrations can be taken up again and again and again. When these vibrations reach our ear, the sound is heard. Our ears are sensitive only to a limited range of frequency from 20 Hz to 20,000 Hz, which is called the audible range of frequency. However, the audible range of frequency for a person decreases as he gets older, since his hearing sensitivity of ears falls for both the low and the high frequency. So we saw that the frequency, we also saw in the last year that the frequency, what is the audible range for our ears, that is the human body can listen to, or you can hear the sound which are of the frequency between 20 Hertz to 20,000 Hertz. So it is between 20 and 20,000 Hertz that a frequency can be audible. So audible range of frequency of sound is 20 Hz to 20,000 Hz, and as such, with age, this particular range is going to keep on deteriorating. So yes, a person who is of the age of around 40 to 50 may not be able to hear 20,000, but may be able to hear somewhere near 12,000 Hz or so. So accordingly, as the person becomes older, the frequency or the range of the audible range keeps on deteriorating or decreasing. The sound of frequency above 20,000 Hz is called as ultrasonic. So if the frequency is above this, it is called as ultrasonic, and if it is below this, it is called as infrasonic. So infrasonic and ultrasonic are the two range of sound beyond 20,000 hertz is ultra, and before 20 hertz is the infrasonic. So the sound of frequency above 20,000 hertz is called the ultrasonic, while the sound of frequency below 20 hertz is called as infrasonic. Both the ultrasonic and infrasonic are inaudible to human being, but they both travel in a medium with the same speed as that of the audible sound. So yeah, maybe they of course they cannot be heard by the human being, but the speed at which they travel in the medium is going to be the same as that of the audible sound. So depending upon the speed of the sound is not dependent on the frequency. It is not at all connected to the frequency. The frequency is the integrated part of the source of the body. So the source of the body is one which is going to determine the frequency. The velocity of the sound is not going to depend upon the frequency. When sound wave travels in a medium, the maximum displacement of the particle of the medium on either side of the mean position is called as the amplitude of the wave. The time taken by the particle of the medium to complete one vibration is called the time period of the wave. The number of vibrations made by the particle of the medium in 1 second is called as the frequency of the wave. So the frequency of the wave is the same as the frequency of the source producing it. So we see the three main important kind of the, we can say that if this is a wave, then according to that thing, this over here or this over here is the amplitude of the wave. Okay, that is the maximum displacement from the mean position on either side of the mean position is the amplitude. This time from year to year, one particular oscillation के लिए जो time लगा, that is called as the time period, and the number of oscillations in 1 second is called as the frequency. So frequency is equal to 1 upon time period is the formula we're going to have. So the distance traveled, and the distance traveled in one time. So from year to year or from year to year, यानी ये पूरा thing या तो यहाँ से लेकर इधर तक, ये this is called as the lambda, that is the wavelength. So wavelength is the one length or distance traveled by one wave. So the distance traveled by a wave in one time period of the vibration of the particle or the medium is called as wavelength. The distance traveled by the wave in 1 second is the wave velocity. So the distance traveled in 1 second. So of course we know the distance is one wavelength and the time taken for that thing is time taken. So the distance upon time is nothing but velocity. So accordingly we have that velocity is equals to distance upon time, or we can say that because 1 upon t is equals to f, therefore v is equals to f lambda. Therefore v is equals to f lambda. So these are some important results what you are going to get from the 9th standard chapters. So the distance traveled by the wave in 1 second is called as the wave velocity. The wave velocity v, frequency f, and the lambda are related as v is equals to f lambda. The time period t and its frequency of wave is related by f is equals to 1 upon t. Note, the frequency or time period of a wave depends on the vibrating source producing the sound, while the velocity of the wave and hence its wavelength depends on the properties of the medium in which the wave travels. So this is very important here, that the frequency is going to depend upon the source of the sound, which is the vibrating body which is causing the sound to be produced. According to that, there will be this particular frequency. The frequency is dependent only on the source of the vibration, whereas the wave velocity, okay, while the velocity of the wave is dependent upon the medium, so it will be hence the wavelength depends or velocity or the wavelength depends on the properties of the medium in which the wave is traveling. So that is the main difference between the frequency and the wave velocity or wavelength. The sound waves necessarily require a medium for their propagation. The transfer of energy by the wave is through the vibration of the medium about their mean position. When the medium particle vibrates, there is a change in kinetic energy into potential energy and vice versa. So sound waves are also called as elastic or mechanical waves. The mechanical waves are of two kinds: longitudinal waves and transverse waves. So we see that the sound waves, they are going to be, the transfer of energy is going to take place because the material medium is required. So because there is a material medium required, that's why there is a transfer of energy from the sound waves into mechanical waves. So mechanical waves which are there, they could be of two kinds. One is the longitudinal wave. If the particles are moving in the direction of the sound, then it is called as a longitudinal wave, that is normally in air or inside the solids or liquids. Whereas if the movement of the particle or the movement of is perpendicular to the direction of the wave, then it is called as a transverse wave, which is normally taking place on the surface of solids or liquids. So that is why we see the longitudinal waves, if the vibration of the medium particle is along the direction of the propagation of the wave, thus forming the compression and rarefactions in the medium, the wave is called as longitudinal waves. For example, sound waves in air, in solid and inside a liquid. The longitudinal waves can travel in solid, liquid as well as gas. On the other hand, if the medium particle of the vibrates normal to the direction of propagation of the wave, forming crescent troughs, the wave is called a transverse wave. Then, for example, sound waves in the solid and on surface of liquid. So you can sound waves on the solid or surface of the liquid is going to be transverse waves. Transverse waves are formed only in those medium which possess rigidity, and that is why they can travel only in solids and on surface of liquids. So that was about the propagation of the sound, which we saw in the 9th standard. So basically we know that when the waves are formed by compressions and rarefactions, so in that case the movement of the particles is in the direction of the propagation of the sound. It is called as longitudinal waves, which takes place inside the solid, liquids or gases. Whereas on the surface of the rigid bodies like the liquids and the solids, there will be transverse wave where the particles are normal to the direction of motion of the sound. A longitudinal wave travels in gas without any change in the heat content of the medium. The speed v of the longitudinal wave, that is sound, in the gaseous medium of the density d at a pressure p is given as v is equals to square root of gamma p upon d, where gamma is the ratio of two specific heats, is 1.5 for air. Since the density of gas increases with the increase in temperature and with the increase in humidity in it, so the speed of sound increases with the increase in the temperature and with the presence of humidity in it. However, the speed of sound is not affected by the change in pressure. So we see that the velocity is given by a square root of gamma p upon d. Now, of course, d over here is the density, p is the pressure, and gamma is the ratio of the pressure and the density at or you can say that constant for heat, because they are given that whenever there is a change in the pressure, temperature, and the heat is going to be there. So the constant of heat content of the medium, okay, the gas, any change in the heat content of the medium is given by gamma. So accordingly we have that the gas will, in the gases, the speed of the sound is going to be increasing with the increase in temperature and with the pressure, with the presence of and also increases with the temperature, and with the presence of humidity also it increases. Hence, however, the speed is not going to be dependent on the pressure, because the ratio of the pressure and the density is going to be constant with this, because if the pressure increases, automatically the volume decreases, so the density increases, and hence the ratio of P upon D is going to remain constant in gases. So that's the reason the velocity of the sound in gases is not going to be dependent on the pressure. The speed of V of the transverse wave in a stretched string depends on the tension T and mass per unit length m of the string. So V is equals to square root of T upon m. When the wave traveling in one medium passes to another medium in refraction, the speed, wavelength and intensity of the wave will change, but the frequency of wave will not change. The direction of the wave of the travel of the wave will also change except for normal of incidence. So we can see there is a refraction also taking place in the sound waves. So whenever the refraction takes place, we have seen that the refraction, light में हम लोगों ने देखा था, the refraction is going to take place only when but when the refraction takes place, when the refraction takes place, it is seen that there is no change in the frequency of the waveform. This is because the frequency is the inherent property of the source of the sound, and that is the reason whenever it passes from one medium to another medium, there may be a change in speed, there may be a change in the direction of the propagation of the sound, but there would not be change in the frequency with which the sound is traveling. So frequency is going to remain the same irrespective of the medium through which it is traveling. Also, it is seen that there would not be any change in the refraction. There won't be any refraction taking place if the sound or if the waves are traveling perpendicular to the surface, or you can say the angle of incidence is 0. The sound wave is different from the electron. So this was about the in fact अभी तक जो भी हम लोग ने पढ़ा, whatever we have learned up till now, whatever seen over now, is a recap of the 9th standard. Frankly, none of these is going to be asked to you in the 10th standard, because all these are just a recap of the 9th standard, so that certain things which are required in the 10th standard could be understood better. It's nothing like there is nothing to learn in this first 2 pages of yours. So whatever you're going to learn is only after this distinction of light and sound waves. So up till now, whatever the we have learned about the amplitude and the wavelength and the differentiation or this particular V is equals to square root of gamma p upon d. All these are not to be learned for the board examinations because they are not a part of the syllabus. So syllabus starts only once you have this particular light and sound waves ka differentiation, and then about the echo. So when the echo part starts, only then the portion starts for the 10th standard. The sound waves differ from the electromagnetic waves, that is gamma rays, X-rays, ultraviolet rays, visible light, infrared, microwaves and radio waves. The electromagnetic waves are formed by the periodic vibrations of the mutually perpendicular electric and magnetic field in a plane normal to the direction of the wavelength. So you can see that the electromagnetic waves are just transverse waves. You know, they just written this in a long form, that mutually perpendicular वगैरह. So but the main thing is that the electromagnetic waves are the one in which the electric energy and the magnetic energy are perpendicular to each other, and hence there is a kind of a wave generation which is taking place. So the electromagnetic waves are formed by the periodic vibrations of the mutually perpendicular electric and magnetic fields in a plane normal to the direction of the wave propagation. The electromagnetic waves are thus the transverse waves, but unlike sound waves, they can travel through vacuum also. The speed of the electromagnetic wave is different in different medium, and its maximum or equal to 3 into 10 raised to 8 meter per second in vacuum or air. The electromagnetic wave transfer energy in the form of photons. So that was about the light waves. So the light waves, you know that there will be transverse waves, which are electromagnetic waves, which are the waves generated by the electric field and the magnetic field mutually perpendicular to each other in the direction of mutually perpendicular to each other, and plus the perpendicular to the direction of the propagation of the sound, or normal to the plane normal to the propagation of sound, so propagation of the wave, which is a transverse wave. So accordingly, we see the electromagnetic waves do not require a material medium for its propagation. They are going to propagate in any medium. It can propagate even in vacuum, and the speed of it is maximum in vacuum and decreases if the density of the medium increases. So this is the difference between the thing. So here we understand that the maximum speed of the electromagnetic wave will be in air or vacuum, which is 3 into 10 raised to 8 meter per second. So distinction between light and sound wave, yeah, this is important. You need to learn this. Light waves, these are electromagnetic waves. Sound waves, these are mechanical waves. Light waves, they can travel in vacuum. Sound waves, they require a material medium for propagation. They cannot travel in vacuum. The speed of light wave is very high, 3 into 10 raised to 8 meter per second in air. The speed of sound is below, that is 330 meter per second in air. The wavelength of visible light is very small, of the order 10 raised to minus 6 meters. The wavelength sound of the sound wave is in the range of 10 raised to minus 2 to 10 meters. And the waves are, these waves, that is electromagnetic waves, are transverse wave, whereas these are longitudinal waves in air. So that is the distinction. Now let's start with the portion which is connected to our 10 standard. So first thing is reflection of sound waves. Sound waves, just like any other wave, when strike a hard surface or boundary of another medium, return back in the same medium obeying the laws of reflection. That is, the angle of reflection is equal to the angle of incidence, and the incident ray, reflected ray and the normal at point of incidence all lie in one plane. The return of the sound waves of striking of surface such as wall, metal sheet, plywood, etc. back in the same medium is called as reflection of sound waves. So the sound waves, because they are just normal waves or mechanical waves, they do also follow the principles of reflection. Accordingly, it is seen that sound waves, when they hit a hard substance, they are going to get reflected back in the same medium, and they will also follow the same principle that the angle of incidence at the point of incidence and the angle of reflection is equal, okay? And also that the incident ray, normal, and the reflected ray are going to be in the same plane. So the laws of reflection which are there for light also hold true for the waves of sound. So hence we have the definition of reflection as the return of the sound waves, okay, the return of the sound waves on striking a surface such as a wall, metal sheet, or is plywood, etc. back in the same medium is called the reflection of sound waves. The reflection of sound wave does not require a smooth and shining surface like the mirror. Sound waves get reflected from any surface, whether smooth or hard, polished or rough. The only requirement for the reflection of the sound wave is that the size of the reflecting surface must be bigger than the wavelength of the sound wave. So you can see that in case of the light rays, we had understood that the reflection would take place only when the reflecting surface is well polished and smooth. Otherwise, the reflection what we'll be getting will be an irregular reflection. In case of sound, it does not require any kind of a shiny surfaces like a mirror or something. It just needs one particular kind of a condition, and the condition is that the size of the reflecting surface should be greater than the wavelength of the sound. So sound waves का जो wavelength है, the wavelength of the sound say the reflecting surface should be big enough. If it is very tiny, then automatically the wave will just pass through. So that's why it will not reflect. But if it is a kind of a wall or something where it can hit and come back, so that's why we are going to have the reflection of the sound is going to be heard only when the reflecting medium, or sorry, not medium, the reflecting obstacle what is there is going to be of a length greater than the wavelength of the sound wave. The phenomena of reflection of the sound is utilized to making that megaphone or speaking tube, soundboard, and ear trumpet. So these are the different kinds of sound waves or due to the reflection of the sound, we are using certain kind of instruments like the megaphone or the speaking tube. There's a tube which is through which one can speak and the other can hear it. So all those things, and soundboards, and also soundboards are nothing but the boxes over there. So soundboards and ear trumpets, which are going to be using the reflection of sound. The reflection of sound in a particular manner, in a particular condition, is called as an echo. So now we see the main thing what we are going to learn in the 10th standard about the sound, and that is the echo. So the first part is about echo. So echo production or generation of an echo. So let's understand that how is an echo generated or formed. So that is the first part of it. So if a person stands at some distance from the wall or a hillside and produces a sharp sound, he hears two distinct sounds. The original or direct sound, which is heard almost instantaneously, and the sound heard after reflection from the wall or hillside, which is heard a little later than the original sound, is produced. The second sound heard after reflection is called echo. So you must have been to many of the hill stations where you got to a point where it's called an echo point. So what is an echo point? What do you do at echo point? Okay, you're going to scream out your name loudly. Okay, Bhavin करके चिल्लाएंगे. So you are going to hear a particular sound. Bhavin. Okay, मैंने बोला तो वो तो तुरंत ही सुनाई दिया because that's an instantaneous sound which was given by you yourself and is going to your ears directly. But the other sound will be coming from the far off hill or a jungle or something which is there in front of you, and it is going to be, so what is happening is that when you say Bhavin, तो फिर वहाँ से थोड़े about a second or so you will be getting a reply Bhavin, Bhavin, ऐसे करके हो जाएगा. So that particular kind of effect what you are going to get about the sound is called an echo. So echo is that particular reflected sound which is heard distinctly after the first sound has completely ceased to exist. So Bhavin के बाद में थोड़ा gap and then Bhavin again, that is an echo. But अगर Bhavin अगर extend हुआ सिर्फ, okay, वो अगर सिर्फ extend होता है तो that is not echo, that is reverberation. Okay, that is called as reverberation. Now reverberation is the elongation of the sound waves, whereas this is the exact reflection of the sound wave. So we'll see if we have got reverberation in the chapter, so we'll understand that also later. So thus we see that the two sound what you are going to hear is the original sound which you produce yourself, and the second sound is heard after it got reflected from the distant object. So that is the echo. So we can define echo as the sound heard after reflection from a distant obstacle such as a cliff, a hillside, wall of a building, edge of a forest, etc. after the original sound has ceased is called as echo. So the important thing over here is that reflected sound. First thing is the reflected sound. Second thing is heard after the original sound has ceased, after the original sound has been completed, उसके बाद जब हम लोग को वो सुनाई देता है, that is called as an echo. So you are hearing, so the reflection from a big obstacle such as distant obstacle as a cliff or a hillside or walls or edge of a forest, etc. after original sound was ceased is called as an echo. Note the reflected sound is heard along with the original sound is not called the echo. So if the reflected sound is heard with the echo, I told you about the form Bhavin extend हुआ सर, okay, और हम लोग हो ऐसा अगर हुआ तो क्या वो echo नहीं है, ho and then you say ho again, okay, when you get the something like a reply coming from there again, this is called an echo. So if it is just an extension of whatever you are speaking, it is not an echo. So the reflected sound if heard along with the original sound is not called the echo. Only the sound heard after the original sound has ceased, the sound distinctly separate from the original sound is called the echo. Conditions for hearing an echo. So what are the conditions required for hearing an echo? So let's understand this part first, that what is the conditions required. An echo is heard only if the distance of the person producing sound from the rigid obstacle or reflector is long enough to allow the reflected sound to reach the person at least 0.1 second after the original sound is heard. So okay, I'll do one thing. This is quite a detailed thing to explain, so it is better that I switch over to the next video so that I don't exceed too much of a time in the this part. So I'll switch over to the next video and I explain you the conditions of the hearing in the next video.